Assalamualaikum. Today I will present about my OEL3 Open-Ended Lab 3 DC machine. My name is Muhammad Akib Mizani. My metric number is 211092022. For introduction, the DC motor convert electrical energy into mechanical energy using DC current. The fact that we can adjust the speed and the fact that it takes less room are the key benefits of adopting this. The ST type of motor, series DC motor, shunt DC motor, separately excited DC motor. Okay. A permanent magnet DC motor uses permanent magnets to produce the field flux based on the electrical connection made between the stator and the rotor. The other three types are categorized. They each have a particular torque and speed. If you can see, this is a figure of equivalent series DC motor. Okay. Shunt DC motor field relates to the armature winding in parallel, or also known as a shunt. Series DC motors wind the field with a minimal number of turns using long wire carrying the entire armature current. Alright. Okay, next this is a figure of equivalent shunt DC motor. If you can see, this is equivalent circuit of shunt DC motor, and if you can, we can see the field circuit get its power directly across the armature terminal of the motor. Okay, next, this is figure of equivalent circuit separately excited DC motor. It shown the field circuit is supplied from separate constant voltage power supply. Alright. Okay, next I will talk about the methodology. Connect to the first one is connect to the figure 4 and 5. Second, have the instructor check your complete circuit. Number 3 is before using the brake controller and magnetic powder brake unit, you must fire calibrate the torque display of the brake control to 0 kg per meter. Set the ohm knob to the 47 position. And next, we turn on and run the machine by press the start button. After that, we increase the motor voltage to rated 120 VDC. The motor speed must not exceed 1770 RPM. And next, manipulate the brake controller to operate and set the torque to 0.1 kgm. Okay, after that, record the motor current, field current. Record the motor current, field current, motor voltage and speed. And lastly, repeat from step 2 by decrease the ohm knob as 45, 44, 40, 35, 30, 25, 20, 15 and 12 and record. Okay, for the DC shunt motor, connect the circuit as figure 4 and 5. Second, have the instructor check your complete circuit before using the brake controller and magnetic powder brake unit. You must first calibrate the torque display of the brake controller to 0 kgm. Set the ohm knob to the 1500 ohm position. Turn on and run the machine by press the start button. Increase the motor voltage to the rated 50 VDC. The motor speed must not exceed 1770 RPM. And let's manipulate the brake controller to operate and set the torque 0.05 kgm. Okay, and next we can record the motor current, field current, motor voltage and speed. And lastly, we can repeat from the step 2 by decrease the ohm knob as 1300, 100, 800, 600, 400, 200 and 0 and record it. For DC separate connect motor, do the same thing, which is construct the circuit using the PCM as a figure 6. Set to voltage source separately as VT and VF. Connect the voltage source with DC machine, speed sensor and mechanical load with constant torque. Number 4 is set the VDC equal to 120 volt. Set the value is rheostat as 75 ohm and 0 tap position. Set simulation control time step 0.001 and total time step 4 seconds. And lastly, run and compare the speed and repeat by increase the rheostat ohm value. Okay, after that, this is figure 4, which is a schematic diagram. Figure 5 is a hardware DC machine, and the last one is schematic diagram. Okay, this is the result, which is we have a node that have current, IF, E energy, and RPM by using those unit, which is 47, 45, 40, 35, 30, 25, 20, 15 and 12. Okay, this is our speed versus torque resistance, and this one is figure of current versus torque resistance. Okay, this is for decision, and yes, we do the same part, which is the value of 0, 200, 400, 600, 800, 1000, 1300 and 1500. And this is our figure of speed versus torque resistance, and this is current versus torque resistance. Okay, we all do the same stuff. And for discussion in this OEL3, we discuss about this limit series motor. First, discuss how to understand the limitation parameter and demonstrate the torque speed characteristic of DC series, shunt wound motor, and separately excited DC motor, and so on. After that, for the conclusion, the OEL DC machine teaches us how to link DC series and shunt wound motor and regulate the motor rotation axis. Okay, that's all from me. Thank you.